Good morning, everybody, again. Thank you for coming. We expect a few more people because I hear the traffic is pretty bad. I come only like 15 minutes away. It took me 45 minutes this morning, so maybe some people will show up. If they do, don't get too upset over people coming in and out. As Isabel mentioned, we run these fairly often, every quarter. We hope that customers get some value out of it, and that's why we appreciate the feedback forms at the end of the workshop, so we know what to present, how to present, if there's any changes you would like to do. Usually we talk about technologies. We talk about the different aspects on how to save natural gas, but not only natural gas. The principles can be used for any source of energy. So in this workshop, I will focus more on our programs and how our programs help you save gas, with some examples on how the customers actually executed their efficiency projects and what savings did they see at the end of it. So let's start with just what our programs are. We have what we call fixed commercial and industrial customer incentives. For most of you here, this will not be of any great value because this is meant for very small, very simple energy users. You put a new unit heater that is higher efficiency, you get $50. Usually that doesn't apply to large industrial customers. Comprehensive energy management program that we kicked off a couple of years ago, in which we help customers set up their energy management program so they can manage energy on a consistent basis. And the heart of our program is really industrial programs and incentives. We call it custom industrial for ourselves. And when we say custom, we mean it. If we find a way to save you energy, natural gas or thermal energy, we will find a way to incentivize you. So unlike some other programs in which you have specific technologies and you have to fall into those technologies, we do not have that. If we can save energy, we will find a way of quantifying it and incentivizing. That's why it's custom. It encompasses every possible imagination, everything that you can possibly imagine saving you natural gas. So how do we do this? We developed this based on our experience in the industry. Most of us who work on my team have come from the industry. We spend years working in the industry. And we know that industry has always used continuous improvement principles. So we essentially use continuous improvement principles here. Knowledge development is the start. First, we give you knowledge. Workshops like this one. How do you learn where to look for natural gas savings? What are they worth to you? Are they even worth looking at? Those kind of things. So we start there. That's step one. Step two is opportunity identification. Knowledge is no good if you cannot identify something in your facility. Not in general, not in the book, in your facility. Third step will be quantification of energy. So now you identify the opportunity. What is it worth? Is it really worth what vendor is telling you it's worth? Fourth step, engineering analysis. You quantified it. Now you put it into context. And fifth and last step is project implementation. This is where essentially you have to execute to get the savings. All the other steps are preparation. If you don't execute the project, there's no savings. We can talk about it all we want. Project implementation is what leads to savings. And the key to this is then we start again. We don't just leave you. We've been in this business since 1994, and we work with industrial customers in our service territory only, so we don't leave customers behind. We come back and we find another opportunity, and another opportunity, and another opportunity. But we always follow the same principles. So when we talk about these principles, we will show today a little bit more about each one of these steps and how it applies to your facility. So let's start with the knowledge development. As I mentioned, customers typically will know how much they pay for utilities. If you don't know, your accountant knows. So somebody knows how much you pay for the utility. What people don't know is where that money is going, essentially. What do they pay for? It's very rare to find people who actually will tell you, this piece of equipment is costing me this much, and this piece of equipment is costing me this much. That's very rare. At best, they will know how much each facility is using, but they will not know how much each piece of equipment is using. More importantly, even when they know how much that piece of equipment is using, they don't know if that's what they should be using. So that's what we're trying to do with this knowledge building. Get you to the stage where you know what you use, where you use it, and does that make sense? Given that we don't know that much, it's no wonder that energy efficiency projects are always looked on by management as something that's not worth pursuing. Because if you can't put hard numbers on how much you're going to save, how long it's going to take you to pay it back, very few managers will sign off on it and say, yeah, let's do it. It's a good thing. That doesn't work typically. And that leads to the missing opportunities. How much potential is there? If you look at worldwide, all the energy that's created in the world, everything, every single possible source of energy, 1/3 goes into industrial sector consumption. 1/3 of all energy produced is used by industrial customers. And then if you scale it down, that happens in the US, that happens in Canada, that happens in Ontario. 1/3 of all energy we produce or buy in Ontario goes to industrial customers such as yourself. Out of that, 50%, half, is wasted. 15% of total energy produced, bought, shipped, is wasted. That's the potential. I've been in this business now for 10 years. I spent 20 years or so in the industry. I can tell you that most industry doesn't know this. And I can tell you that most people, when you ask them, would say, no, we operate as good as we can. Damn it, we're the best. And I'm here to tell you that mostly you're not. So how do you find the source of Steed? How would you use it even if you found it? Would it be worth recovering? Do we know those answers? Typically, we don't. This is why we offer these sessions. This is why we put a lot of effort in creating these. These slides are not bought. They're not created by somebody else. They're created by us. For every workshop, we create new slides to help you out, to get you that knowledge, built on the knowledge that we have, build on the knowledge that we collected from you, working with you, to help other people move from the status quo that we are in today. So we have newsletter that we email quarterly with some tips how to save energy. We have website everyone can access to. Videos such as this one will be posted, so you can look like 3 years worth of videos if you want. There's a collateral case studies of some of the projects that we've done in the past. There's simplified energy savings calculators. If you want to know what some opportunity is worth to you, you can quickly calculate it. All of that is available. Funny enough, this morning I was actually showing to my team members, I got an email from China, directly from China, from somebody trying to work with us on some new HVAC units that they have, because they went on our website and found out that that's what we do. So people read websites. I would encourage you to visit it. But the key resource difference between our program and all the other programs in Ontario is energy solutions consultant. Guys in blue shirts that work on my team, they will come to you. They are the key. They're not a website. They're not somebody that you can just put into the form. They can actually think. They can help you how to get the most out of your facility's energy use. And the reason that we do that is we are focused on maintaining long-term relationships. As I said, we've been doing this since 1994. We don't have expanding base of customers. We are not going into Union Gas territory and get their customers. We're not moving to Alberta. We are working with the same customers here. So for us, it's really important when we tell you you're going to save something that we are serious about it and that we show that that happens. Because you will not believe us next time around. And if you don't believe us, if you lose that trust, there will be no projects. So we are very careful about that. You will see us very often being in contradiction with what your vendor is telling you. Because we like to be on the conservative side. We like to be on the side that we know you're going to save this much. If you save a little bit more, great. But we will not go and tell you to go tell your management you're going to save 3 million kilowatt hours or 3 million cubic meters, and then you save million. Because that can be career-ending move. and we understand that. The other thing that we do, we spend a lot of time understanding your processes. People always, when they start talking about energy efficiency, usually what you talk about is, oh, I have the heater that I want to replace. I have this little thing that I want to do. But where energy is used is in your processes. If you can reduce energy in your process, that's where the big gains are. So we try to understand it. We try to work slowly with you so we don't scare anybody off. It's like, oh my God, you can't touch my process. But we build that knowledge and we help you save energy where it matters. And the third part is we are providing an unobstructed perspective. What that means is usually when you work in a facility, you're part of that culture. You tend to view things from the inside, from what you already know. When I was hired many years ago in automotive sector, I was hired from the custom plastics machinery. And I asked my manager, why did he hire somebody not from the Ford or somebody else? Why did he hire somebody from other industry? And he said, if I hired somebody from Ford or Chrysler or somebody like that, I would get what I already have. I don't need that. I need somebody to tell me, what the heck, guys? Why are you doing it this way? This is stupid. Nobody else does it. So this is what we provide. We know your facility. We work with you. We respect the relationship that we have. But we are not influenced by the culture of your facility. So we can say, hey, maybe we can look at it the other way. So that's what energy solutions consultants will provide for you. Step 2. Now that we built the relationship, we gave you some knowledge, let's look for some opportunities. What do we mean by that? Number 1, reduce or avoid the heat loss. This is the opportunity hunt that we are after. Everybody goes for the shiny new things. Everybody thinks if I buy a new piece of equipment, I will be the most efficient person around. That's not necessarily true. But more importantly, you may not have the funding to actually get that done. So can we find some energy savings in what you already have? That's that reduce part. If you reduce your energy use, you will be the better efficient. Second, smaller part is recover. If you cannot reduce it, then at least recover the waste heat that you cannot avoid. So if you cannot reduce your boiler consumption anymore, well, now put economizer on it and recover the heat that goes up the stack. That's what that means. And only then replace equipment as budget or competitive pressures allow. You will notice that replace is the smaller part of this pyramid. And that's for a reason. Very few people will have funding every time to buy something new and shiny. And most people will run the equipment they already bought very badly. You have to remember also that losses are compounding all along the distribution chain. So heat to load is remarkably small once you think about it. Heat that your product actually needs to do the process you want within the quality you require is very small part of the energy you pay for, tiny. End-use equipment will create some losses. Delivery system will create losses. Energy converter, boiler, air compressor will create losses. So what you pay for, what you see on your meter, and what your process requires are two entirely different things. So if you want savings, this is where we look. Because whatever you can save here multiplies the loss gain up the chain. And this is not just natural gas equipment. Air compressors, 80 to 85% of kilowatt hours you put into air compressor is waste heat. You get nothing out of it. I don't care if you have VFD. I don't care what you do. You will lose 85%. So 100 kilowatts, you only get 15 kilowatt there. And of that, you waste 7.5 kilowatt on your leaks. That happens with boilers. That happens with all sorts of equipment. The other thing where we look for opportunities, natural gas in manufacturing, you rarely use it as a flare. You don't just fire up the flare and have a nice little barbecue at the backyard. You use it in some sort of a process. And process for natural gas typically means heating. Whether you heat product itself in some sort of furnace and you heat a piece of steel, whether you heat air that then heats the product, or for ventilation or whatever it is that you need air for, or water, heating water. Again, it can be heating the product indirectly. It can heat air indirectly. It can be used as a steam. So as a result, natural gas savings are usually found if you look at your processes. Very rarely will you actually gain significant savings if you buy a small piece of equipment from the catalog and you say, ooh, look, it's efficient. Those are tiny, and for industrial customers, those will be almost negligible savings. Where savings happen is in the changing of the process. Not changing how your process in the product work, how the losses around it are dealt with. So for example, spot the opportunity. We have oven. Every oven in Ontario under the CSA, and not CSA, TSSA, has to purge 4 times its volume before it's lit up. So not to wait 2 hours, we have exhaust volume that enables that to get us purged in 15 to 20 minutes maybe. The problem is operational requirements for that oven are much, much, much smaller. Fraction. So there is a big discrepancy between what oven actually puts into the air through the stack and what needs to be put when you're running it at a production level. This is one of my favorites. This is my personal favorite. If you have this in your facility where one guy is wearing a vest and a winter coat, the other guy is walking around in the shorts, there's your opportunity for savings. Third one, if you look at your consumption over 3 years, and I use 3-year average because that gives you, if year was especially difficult or if it was warm or whatever, you avoid those slight peaks. If you look at the consumption and you put it in this way, and then you look at where the consumption actually went, in this particular example, 24% of the consumption was done on the weekends, and weekends and non-working days represent 29% of the year. And then you talk to the customer tells you, oh, I'm working 24/5. So that's obvious opportunity to ask, why is your consumption on the weekends then the same as on any other workday if nobody is in the facility? And we'll jump into one of our exercises right now. You have in activity book, exercise 1. There is no right or wrong answer necessarily, but we want to take a look at this facility. 160 feet wide, 400 feet long, 24-foot ceiling. It's located in our GTA area. And the question is, you have the consumption at the back, on the page 3, for this facility. It uses 1.1 million seasonal load, 1.1 million cubic meters. And what I would like you to do is, if somebody could tell me if you can spot the opportunity. What do you think opportunity is here, given the information that we have? You can write it down. You can raise your hand. We'll give you a couple of minutes to think about that. Anybody willing to give it a shot? Kevin? Yep. Very good. Very good. First person willing to raise their hands. Thank you, Kevin. Oops, sorry. Any other interpretations, Carol? Very good, too. So the graph can tell us a lot of things, right? We didn't do much work. We just plotted our consumption, and it already raised 3 or 4 questions, all valid questions. The other one that I would also like you to think about is, we're talking 64,000 square feet of space. And it takes us 1.1 million cubic meters to heat it. If you divide those two, it means 17 cubic meters per every square foot of space. That is an enormous number. It might be something that is really necessary, but if I see a number like that, I automatically go, let's analyze where this energy is going. As a rule of thumb, we use for 1 foot squared of floor space, it should take you 1 cubic meter per year of heating. In industrial manufacturing facilities, actually lower than that. It's probably around half that. But even in a warehouse space, this is the rule of thumb that I usually look, and if the number is above 1, I go and I investigate why is that. So if your manufacturing facility is using more than that, talk to your energy solutions consultant, sit down. They will get information from you that they need to do some basic analysis to say, why is it that we use that much? All right. So not everything can be determined this way. We've seen 3 different ways of spotting an opportunity, but not everything can be found this way. There's other ways of doing it. People need more in-depth analysis. We have worked with people who have very specific paint line requirements. And those people will then require a very specific design engineering analysis to find out where opportunities are. If that's the case, we will work with your vendor of choice. We give you financial incentives for that, but we ask to be engaged at the beginning, at the definition of the scope of work, what the vendor will do. And we do that for a number of reasons. One is because we have done initial analysis. We have done some history with your facility. We know roughly what are the gaps in the knowledge, what gaps we need to fill by that study or by that assessment. So it's not one of those walk-through assessments that somebody goes around and says, oh, yeah, you have opportunities, $2,000, please. We want these opportunity assessments to be very specific and focused. The other thing is provide context, because otherwise, I don't know this, I don't know that, I have to collect this, I have to collect that, but we might already have that. So you can give it to them as part of the scope of work and say, here, we already done this, what can you do? What can you do that we haven't done? We don't pay 100% of the cost. We typically stop at 50% of the cost, and that's because we have found we've done 100% of the cost coverage before, and what we have found is customers are more than willing to do analysis and assessment. They pay nothing into it. They get the report, they put it on the shelf, they say thank you very much, and nothing ever happens. There is no skin in the game. There is no interest to actually get something done. So we want customers to have interest in actually executing something they want to work on. There's time-limited campaigns. Every now and then we will have a campaign. A couple of years ago, we had air balance campaign where we paid for 100% of the cost of the air balances because we think that's where the opportunities are and you can actually benefit from it. When we talk about assessments, what should they actually consist of? So they should identify specific opportunities. It should not be a walkthrough. You should never pay for a walkthrough assessment. I don't understand how that happens, but I know people who do. What will walkthrough assessment give you that's worth your money? Define current state. So every assessment should say, this is how you operate, for sure. Not like, we think this is how you operate. No, no. We went through equipment you have. This is how it's operational. Provide overview of what changes are required and how to achieve them. It's one thing to say, man, this piece of equipment can operate 30% better. No, no. What are you going to do to make it 30% better? And you don't have to have in there all the details. There may be some sort of secret for them. But what principles will they use to reduce it? The blue one always gets me. There is never energy saving mechanism in these assessments. What principle, what physics are you going to use to reduce the energy? Is it going to evaporate less water? Is it going to use less air? Is it going to use less water? What physics underline your statement that it's going to use less energy? Provide an estimated savings based on preliminary calculations, and list all input assumptions and identify most impactful ones, so that you, when you read the report, you know where you could be tripped and what are the risks if the input assumption is not correct. So here's a detailed description of one of the studies that we've done recently. We'll include it, that included their engineering report. So look at the detail of engineering report. What engineering report will list? Every single step. That is assessment. And this is the excerpt from that report. So you can see that they actually prioritized. Task priority 1, how much energy savings potential? What's the estimated cost for implementation? Priority 2 tasks, same thing. And then for each one of these, they actually listed what are those opportunities? How will they save? What needs to be done to get that saved? That's what assessment should look like. If somebody gives you a piece of paper and say, here, 15% savings, let's do it, why are you paying for that? So in summary, assessment should leave you with no doubt, as a decision maker, with no doubt why is it that you should be doing the project and what are your next steps. You should read the report and you should say, okay, now I know why I'm going to do it and I know what's next step. If they haven't done that, they failed in their assessment. It should include a list of factors that will jeopardize you. So if they say, we estimate that you can save, that this airflow can be 30% lower, but we are not sure, that's fair. Maybe they really don't know. But at least they identified it, and then it gives you opportunity to say, let me go talk to my floor guy and see if we can actually get 30% savings. Because if you can't, then all of the rest of the assessment falls apart. Another thing that is big no-no for me, assessment should not result in a request for another assessment, for God's sakes. That just shouldn't be done. That's why we're paying you money to do the assessment. Yes, there could be some additional sub-metering, there could be some additional probing, but not yet another assessment. I used to install capital equipment for automotive manufacturer, tier 2. And when we bought robots or new piece of equipment, shot peening equipment or whatever, at no point, zero chance of vendor coming to me and say, here's a quote for a quote that I will do a quote for you. Like, that just didn't exist. Tell me what you're selling me, tell me how I'm going to benefit, and tell me where to buy it. It wasn't like, well, you know, if you give me $20,000, I'll tell you what to do. We would laugh them out of the building. Yet in energy sector, that's somehow accepted. And I don't understand why. So you should have enough details coming out of the assessment to discuss quotations for a job. You should have that assessment in front of you. Call your vendors and say, hey, if you make these changes, how much is it going to cost me? That's what good assessment is for. So identification. Why is there identification then quantification step? It's exactly what Carol was referring to. How many of you have purchased new production equipment? Is anybody here actually involved in buying new production equipment? Nobody? Yeah? Yeah. So did you buy the first one that vendor proposed? Or did you actually ask, hey, does this fit specifications I'm looking for? I'm concerned that there is no answers. Because I can tell you, we were putting a robot. It's the first robot in the coil, you know, with the springs for the cars. When they coil them, red hot steel. It was the first robot in North America that we installed that moved from the coiler into the quench. And as a first robot, we made 16 million coils a year. We had to make one coil every 3.8 seconds, exactly. And I can tell you that there was a hell to pay if 3.8 seconds was violated in any way, shape, or form. So when we bought a new robot to get into that place, we actually flew to Japan to test the robot at Fanuc Center in Japan. And we were testing until we got from 3.95 seconds down to 3.8 seconds. We wouldn't let them ship it until it was 3.8 seconds exactly. Because all of our jobs would be cut if we were at 3.9 seconds when the robot was installed. So it's very important that specifications are followed, that you know what you want, and then you ensure that it actually does what you want. That happens with most of your manufacturing equipment, I have to believe. Same thing. Was there a post-installation review if you actually achieved that? Our post-installation review was the every morning's meeting, manufacturing meeting. What happened in the last 24 hours. And I can tell you that there would be a lot of screaming if that robot was not performing in 3.8 seconds, because the rest of the line would fail. We couldn't ship the coils that we promised to ship, and Chrysler would charge us $20 million in penalties. It's not just Chrysler, I'm not picking on them. Any OEM would charge you money, significant money, if I put their line out of work. So there's repercussions to that. And I'm not saying that energy efficiency projects have the same weight. They don't. We have to admit that. They just don't. However, that doesn't mean that we can just accept any claim we want. There's still a level of professionalism that both vendor owes you and you owe yourself. So what opportunity quantification is essentially a sanity check. If somebody says you will save this much, does that hold water? Does that make sense? That's what quantification step is. So it's either to confirm input assumptions or to relate calculated savings to some known baseline. As Carol said, if I don't know what this piece of equipment is using, how do I know if the savings are realistic? Who needs to generate a business case for energy efficiency projects here? Can I have the show of hands? Who needs to generate a project? Okay, about half. What is your project's justification strategy? What do you say to the management when you ask for money? Will you pay it back in a certain amount of time? Is there payback criteria? What do you guys use? Okay. Okay. So did anybody have to go back and present actual savings 12 months from then? How did you do that? Good. So for people like you, quantification step is the most important one in the process. Otherwise, what you measure afterward will not match what you promise, which doesn't make good career move, generally speaking. So for us, quantification step, we want to confirm these input assumptions in a most cost-effective way, because we don't want to take a lot of money that could be spent on actual project execution just to measure something. Sure, if you have lots of money, you can measure everything, but is that needed? So let's give you an idea of what I mean by the role of quantification step. Why is that important? We dealt with a customer who wanted to replace air handling unit equipment. That was my customer years ago. They wanted to replace oldest of 6 identical air handling units on their facility. So they came to me, they want to do that. Vendor said, yep, but don't use 80% efficient indirect fired unit like they had. put a new one in, which is direct fire heating at 92% efficient. Keep the same air volume, therefore you will get 12% savings because efficiency is 12% better. Sounds good. Looks good. Okay, so we got involved. Took a look at it. Okay, this is how you calculate Q before, energy that goes in before, airflow times delta T essentially, divided by the efficiency. So if the efficiency is better, you will get less energy, you will show savings. That is not a question. The formula has been used for probably hundreds of years, hasn't changed, it works. If I know all of that, I can guarantee you that my formula will give you accurate result. The problem is it correct answer? When I came out of engineering school, and when I started working in the custom machinery, plastics machinery equipment manufacturer, I used to be in charge of all the special projects, of all the special dies that we did. And I went to my manager and president of the company, and I said, how do we know that what we draw here, that what we make assumptions on will actually work? And that's the question that always pops up. How do we know what we draw up, what we come up with calculations, will actually result in life? And he said, well, you know, it's a combination of experience. Sometimes you fail, and then you learn where you failed. So same here. Even in this example, we have 5 inputs. CFM was the airflow, was the temperature that we want to set it at, was the temperature on the outside, what's our efficiency, and how many hours does that equipment work? So before and after means we have 10 assumptions. Only 2 we have explicitly stated here. So how do we know if that result is correct? How do we know that nothing has changed? That's where quantification step comes in. This is what we want to get to. And where to start and where to focus on is very important, because some variables are more important to get right than others. So to start with, we always recommend customers have a baseline. Do you know how much energy you actually use today? And if you want to replace a specific piece of equipment, how much energy that specific piece of equipment is using? Not in general, not in average, not industry averages. What is your equipment using? Because that's the only way you're going to judge if your answer on a piece of paper is close to correct or feasible or not. So what do? We can either consider looking at the big picture things. So for example, we can say, okay, we don't want to know exactly one unit heater. We want to know all of our unit heaters. So it's a type of equipment, or what is this department using? Or we can focus investigation on a specific machine. So if you want to replace an oven or a dryer that uses, or boiler, let's just focus on that. Don't worry about the big picture. But in either case, it does not mean that we want to measure natural gas. And the reason for that is natural gas metering is very resource heavy. Even to this day, it's much more involved to meter natural gas than it is to meter electricity or water. And we understand that, so we are not going to go around and install 17 meters everywhere in your facility. Because, yes, if you have money, sure, meter everything, no problem. But even for those who have money, how many can take the equipment out to put a meter into the line? Right? And how many can actually spend that money on a project rather than on metering every single detail? So we need to use critical thinking. Where do we want to put the meter? Or where do we want to meter the input assumptions that go into calculations? What is more beneficial? So either way, whatever we do, data collection and rigor with which we collect the data will depend, of course, on what's the data that we need and importance of that data point. And that's another thing that your energy solutions consultant is well versed to actually tell you, hey, based on 300 projects that we did, this is not really important to get right. But this one, let's focus on this one. Let's really measure this one that we know. I cannot tell you how many times we had customers wanting to replace water heater telling us we're going to save X amount because this water meter uses this much water. Then we went and put the water meter, one of those ultrasonic water meters on the pipe, and left it there for a week at no charge to the customer. We read the data, and it turned out that they used 1/10 of what they thought they're using, because all they can think of is a peak. But then after 15 minutes of peak, they use next to nothing. And we were like, look, maybe money is better spent somewhere else. So let's do another example and another exercise, and then we'll take a break. So let's quantify energy use. This company, Improved Global Industries, uses natural gas for two main purposes: for heating the space with 2 unit heaters, and for process equipment steam that's created by the steam boiler. Natural gas is going through the facility meter, and only monthly the consumption is available. So even us cannot see anything more than monthly consumption. You want to know, based on this consumption that you have over the years, you want to invest in metering. You want to know where this gas is going, but you want to determine what is the least cost option that yields the maximum operational insight. So for this type of customer, this layout of the equipment, yellow is the gas lines. What meters you think you should be purchasing, where you should be installing them, or should you use some other methodologies? The goal is to find the least cost option. And then you can put roughly what you think would your option, your solution cost. So again, whoever does it first, we have a little gift. There's no right or wrong answers. Yes?
So we'll meter your boiler, subtract that off your incoming meter, and then you'll have a virtual meter for your unit use.
Close. Very good. Except you only have monthly consumption on your meter. But yes, that's what I would do. So this is monthly consumption. So yes, that's answer is correct. What I would then do is I would actually go and get my an energy solution consultant to arrange for an option of reading the data of the, thank you, of the meter. So you can actually attach a little box on your facility meter that will read the data and allow you to read data from here in any which way you want. So if somebody didn't catch this, what Doug was referring to is because of this production, because of this ratio of process load versus seasonal load, obviously process load is much higher. So he says, let's focus on the steam boiler. Let's put a meter here. And then let's subtract off of here, minus this is what goes there. That's a perfect solution. The only caveat, as I said, I would ask Enbridge to help us with getting the read of this meter into my DCS system in the facility, so I don't have to wait for monthly data. I can get hourly or daily or whatever I want.
You have to have a minimum consumption to get that?
No, you just have to have compatible meter. Yeah, most of our meters are compatible, and for those of, that's why I'm asking you to ask energy solution consultant, because they can quickly dig out the data. Yep. Yes, yeah. Almost all of industrial customers will have meter that can be attached. Okay, so let's take a break, and then we'll talk about a little bit more on all these virtual meters and metering in general. How to make the data collection more affordable. We'll talk about how to capture output from Enbridge's main meter. We'll talk about how to use virtual meters, how to meter air or liquid flow rather than the natural gas directly, and we'll talk about insertion meters. So let's start with the capturing output from Enbridge meter. I find that to be probably the most cost-effective method other than using virtual meters on getting your information. It allows you to collect real-time data from the Enbridge meter directly, and you can record the energy usage at the intervals of your choosing. That is very important if you do any sort of energy management. Aside from quantification of the projects, if you do energy management, you want to have data collection for energy at the same intervals as data collection for your production. So you can correlate the two. There's no, yes? Depends on what type of customer you are, how big the meter is, what it reads. But essentially, this will read every time meter turns, it'll give you a signal. So you can, whatever you want. That's how this works. So in quantification terms, what we talk about here, this methodology on its own will not get you far because you still need to know what else you have in your facility. But it's useful to many, many customers because some of them don't have any more than, say, monthly data. So if you want to have daily data, hourly data, the only way you can get it is if you read your own inputs. This is what it looks like. This is Mercury main circuit board on our meters. You essentially attach a wire to the SPA pulse output board. You put a safety barrier so that we know that your data cannot damage our meter. And you put it into customer input device, which is your data collection system, your spreadsheet, whatever it is you want to put it in. So essentially, data flows from the meter into your input device, and in return, we get power from your input device, usually some sort of PLC or some sort of input-output board. So that's essentially all this. This part here and this part is what gets installed on your meter, and you're off to races. So essentially, install must be done by the Enbridge authorized vendor. There's a UMTS that we always use. Because it's a natural gas meter that's used for billing, nobody else can touch it. You cannot have your own vendor. You cannot do it yourself. It has to be our approved vendor. However, if your meter supports this method, and most of yours will, the typical installed costs all in are about $2,000, and we pay half of that. So for $1,000, you get data collection device, which is, I think, a pretty fair deal. Any questions like Kevin had on wireless or stuff like that, that's the person you should be asking, the installer. They're very knowledgeable. They've done systems like this for years and years and years, and they'll be able to tell you whether there's some other methodology. So the other method is, as Doug has pointed out, virtual meters. Essentially just calculates energy use based on two other meters that you already have and subtracts the values, gives you an idea of how much you use. We recommend this methodology for minor users. If they're not really important in typical manufacturing facility, your unit heaters would be ideal for this because they will use such minute amount of energy that if you're off by 50%, you will still make 1% error on your total project. So being the virtual meter is the cheapest of all. It's just a matter of calculation. And it's used in conjunction with some other metering methodologies, typically from this utility meter. Somebody will capture data from the utility meter. They will use that as a total. They will subtract some other meter, like Doug has pointed out on that steam boiler in our example, and they will get virtual meter values. That's all it is. So for example, in that, we would have capture data. We would have meter on the steam boiler, and we would subtract the two to get the virtual meter data on these unit heaters. Simple as that. So you only have the cost of the sub-meter and of capture data. For a little more complex application, you would have meter on your steam boiler going into the boiler room. You would have meter on your major piece of equipment that you know you use a lot. You potentially might have a meter on your air makeup units if you have a lot of seasonal load to track that. And then you would use virtual meter for your unit heaters. So that's an example in a little more complex setting. Then the next methodology is very important for us, measuring other sources of information, confirming input assumptions rather than metering natural gas. And a lot of people will say, well, that's like a virtual meter. But the difference, key difference is that now we are measuring the energy driver. We do not try to virtually meter or meter actual energy. We're metering energy driver, what drives that energy. So that's what we mean by, it usually ends up being you either meter air or liquid, because those are the two things that you heat. To judge whether you're measuring the right input, you will need to do certain sensitivity analysis. If I have these inputs, and these inputs are off by 20%, how much will that affect my savings? So that's what you want to do before you jump into metering all these things. So again, energy solutions consultants are more than happy to say, hey, this is what we've seen, this is how we would do it, this is what we recommend. Excellent method if you're trying to establish consumption of things like water heaters or makeup air units or steam boilers. Because if you put a meter on those units, not steam boilers, makeup air and water heaters. If you put a meter on air volume or on your water volume, you will get very cost-effective way of measuring your natural gas. Goal is to establish the subset, for example, of units. You can do that on makeup air units in multiples, or you can do it on the water heater, one makeup air units, however it suits you. And whatever it is that what the savings will drive this. So how would we do this here in this example? We would, for example, not use meter on the makeup air unit. We would put air balance study in place. And the reason for that is because air balance study can measure all your airflows for about average manufacturing facility, $5,000 for, say, 6 or 7 makeup air units. And if I know the volume of air going through your makeup air unit, I can tell you within 5% what your natural gas usage is. So there's no point in metering all of those makeup air. In this example, you're only eliminating 1 meter because I have this main line that goes to 2 makeup air units. In real life, you could have multiple lines going to multiple makeup air units, and then you need multiple meters to actually capture it all. Yes? For me, we would always recommend metering water and natural gas. You could also do the steam meter. It depends what is more cost effective or how important the number is.
So the natural gas goes to the main boiler.
Exactly, yeah, yeah, yeah. Yep. Steam meters are usually relatively expensive to install, and the problem with steam meters that I have from my previous experience is they go out of calibration often, so you have to recalibrate them. We have Akil on our staff, technical staff, who is more than capable. If he has natural gas usage and water usage, he can predict exactly what your boiler is going to produce. So it depends on how important that piece of information is. Some people will use steam consumption where they send it to charge other department for usage, for example. In that case, you need a steam consumption anyways. You might as well use that rather than metering other inputs. So again, this is roughly what your savings are. Gas meter installed, $3,000 to $5,000 typically. Cost of water meter, $500 to $1,000, really fancy water heater. And airflow measurement, as I said, you can get air balance for $7,500 without any problems. And you can get all the idea how much air your facility is actually using and where. But if you can't measure the energy driver, you can use virtual meter, and you really need to submeter the data, for example, on the boiler, on some piece of equipment that you can't calculate. Then there's 2 ways you can measure it. One is inline meter, which is your typical what you see on any major station. Your house meter is an inline meter, where the pipe stops, then the meter goes in the place, and then pipe continues out of the meter. Or you have insertion meters, where this meter gets inserted into the pipe. So 2 different types. Insertion meter, you essentially put a weldolet, you weld it into your pipe, drill a hole, you put isolation valve in the weldolet, and now you can hold that isolation valve closed, so you don't have to have meter right away. You can just prepare it. And then when you're ready, you open isolation valve, you put insertion meter in it. and that's it. This can be done hot, meaning you don't have to take the equipment down, which is a great advantage for some people who need to run 24/7. It's not meant for every metering application. The big thing that we always hear is, oh, it's not billing grade. Yes, it's not billing grade, but how many of your projects are really accounting center quality? Who are you going to bill for that? If you plus minus 5%, does that really matter? No. Right? And it's for pipe sizes over 1.25 ID because the tip goes into the pipe. So if the pipe is smaller, it's going to restrict all the flow. The other side of that, again, is if you have that smaller pipe, the gas user is so small, I would use virtual meter or some other, or meter the driver rather than the energy itself anyways. So for most cases, I would use insertion meter for quantification. The other things are upsides of this unit. What is important about this particular meter that inline meter doesn't have? One is there's no bypass required. If you're going to put inline meter, you have to cut your pipe. And if you don't put a bypass in case meter fails, you will have failed equipment. You will not be able to run your equipment. So we, as a general rule, will not give you incentive for putting inline meter unless you're putting the bypass. If we learned that the hard way, we were sued once because the customer's equipment was down because the meter was out of whack. Even though we told them to use the bypass, they didn't want to. You have to remember putting the bypass adds another $3,000 or $4,000 to the cost. So in the end, it costs you more. The other thing that I like about insertion meters is flexibility in installation. Remember those isolation valves we were talking about? Let's say you have a paint line. Now let's say you have a cure oven and bake oven, a dry off oven and bake oven. So you have two pipelines, two pipes going into each oven. Now you can put isolation valves on both of them for about $1,200 on one and on the other. And now what you can do is you can put, when you're ready, you put insertion meter in this one. You keep it there for a couple of weeks. You see how the line runs. You get a sense of how much energy is using. And then you take it out of this one and you put it on the other one. You don't need to pay for 2 meters. Remember, this is not energy management system. This is quantification of the project. And if you later decide that these are really critical pieces of equipment and you want to monitor them all the time, you just buy additional insertion meter. You already have everything in place. I don't know for the Ethernet, but yes, you have to, for us to give you incentive, we actually require you to put it into some sort of data collection system. Again, historical lessons are, hey, Joe, go read the meter every morning. Turns that into, I read it at 7 o'clock, I read it at 9 o'clock, I read it at 11 o'clock, I don't show up. And then your data is completely messed up and you can't really use it. So we ask customers to connect it to some sort of data collection system as a rule. So yes. And therefore, installed costs of these insertion meters is often less than the cost of the bypass itself. That's why we champion these usually. So as a brief summary, quantification step, what we talk about quantification step is not post-meter and verification step like other utilities have. That's not what it's meant to do. Quantification step is not meant to verify your success after the fact. Quantification step is actually meant to help you get the project approved. So that when you go to the accounting, when you ask the money people for the money, when you ask CEO for investment of $1 million, you can tell them, no, I know exactly how much I'm using here, and I know what the cost is that I'm saving and how I'm going to save it. That's the goal of the quantification step, not M&V. Questions on that? No? Okay. Let's go to the next step. Now we have quantified input assumptions. We have formulas. We identify the opportunity. Let's do engineering analysis. What does that mean for us? It's where we put it all together. Now you know what your input assumptions are. You can relate in those input assumptions to some sort of actual usage because you measure them. If the calculations match what you expect from your baseline, then you can say, yeah, I confirmed the assumptions. They all make sense. Now I'm fairly certain I'm going to get this done. You do perform, in this step, you also perform sensitivity analysis. What if scenarios? What if I'm wrong by 10%? What if I'm wrong by 30% on this one? And the last step that most people miss is establish impact on the non-energy benefits. And we'll talk briefly on that as well. So if you recall that example that we had where they wanted to replace air handling unit with 12% more efficient one, what would engineering analysis look like? What would we do? So what we have done, we turned into sanity check. We said, okay, this is your annual usage in this facility. This is total natural gas that you use. Remember, they have 6 makeup air units, and they have some other equipment. So out of that consumption, the bottom is process load, so you cannot affect it by your air handling unit. Only seasonal load can be affected by your air handling unit. We agreed with the customer that is reasonable seasonal load. There is no process in there. So we took that, and we said, okay, estimated savings are this much of my load. But remember, savings were 12% of the usage. So if 12% of the usage is this much, it turns out that that particular unit would use 60% of all their seasonal usage by itself. And the question was, is that reasonable? Because you have 5 other ones identical, operating identically. So is it reasonable to expect that only one would be 60% of your usage? So what turned out to be, when we saw this, and we called the vendor back, and we talked vendor, customer, myself, what it turned out to be is that they were based on 12% better efficiency, sure. But assumption was made that the unit operates at the nominal CFM, what's said on the unit itself, year-round, all the time. The problem is, remember that the unit was indirect, and therefore it had recirculation. So only 20% of the air was actually fresh air. Everything else was circulated. Well, now the savings and the consumption are much less than what originally was thought of. So customers still went and replaced the unit, but with the knowledge of what's going on. And they actually replaced it with the same indirect one because it allowed them to only run 20% fresh air. So even if it's more efficient on the, with the direct air heating, what happens is you have to have 100% fresh air. So now 100% of fresh air versus 20% of fresh air is much more energy consumption than 12% savings in the efficiency of the combustion, which would not be caused if we didn't do sanity check, if we didn't know what to compare it to. Because 12% looks legit. 92 versus 80, there's no question about that. But 12% of what? So we found that was done. What about cases where we are not sure about post-install values? So the input assumptions that are as-is case, we can measure. We know what they are. What about post-install values? We have no idea what those are. By nature, by definition, they're post-install. Until we install, we don't know what they are. So what do we do about those? So we still make those assumptions. Makeup air unit will operate at some efficiency. That's an assumption. Fresh airflow will be a certain CFM. That's an assumption. It will be outdoor temperature of some sort. And it will be heated to some indoor temperature. So that's still 4 assumptions. And of course, how long is our heating season? 5 assumptions in the future. And lots of time, makeup air units or any other heating will be designed for the coldest day. So what they think of outdoor temperature is different than what your average outdoor temperature throughout year is. So you have to be able to judge what is your input. How are you going to quantify that? It's one thing to say this makeup air unit has to be large enough to handle even the coldest day, and to say this makeup air unit actually uses this % of energy because over the course of the year we have coldest day only 1 day a year. So that's why we have to be able to judge that. And how we do that is just simply understanding what is important to get right. What are the inputs that will kill us? What are the inputs that we can live with? No different than when you buy a piece of equipment. Will that actually perform as we want if we tweak it a little bit? Or no matter what tweaking we apply, it will never work the way we want it. Same with this. The other thing that I want to point out is when we do a sensitivity analysis, a lot of times energy efficiency projects go one of two ways. We are very optimistic. We trust the vendor. There will be 30% savings. We put 30% savings in our business case. Or we are skeptical, like me, and we put conservative values. And we say, I don't believe 30%. I'll put 10% to be on the safe side. Just enough to get project approved, but I don't want to put myself out. The problem with that approach is that you're missing on the savings. Sometimes that 10% going up to 15% can actually make or break a project, because all of these projects, I don't know about you guys, but most of our customers will actually have these projects compete with all other capital projects. There is no big difference between energy project and capital improvement project. So you want to be as good in your business case as possible without being overly optimistic or outright unreasonable. But there's no point in being too conservative or too optimistic, just as there is no point in being too optimistic. So we want to use this sensitivity analysis to tell us, hey, if I just improve, if I look at this input assumption, if I can confirm it that it is what it is, I can improve my business case by 5%. Sometimes that 5% can make or break the case. So let's look at the sensitivity analysis for this makeup air unit. This formula is essentially mass times specific heat times delta T converted to airflow. 1.08 times CFM airflow times delta T in BTU per hour. Simple as it gets. Q airflow is heat required to heat the amount of air that we have. CFM is airflow in cubic feet per minute that goes through the unit. Indoor set point, outdoor set point. So if we put CFM, 20,000 CFM, if we say that we want to heat it to 72 degrees F, and that outdoor temperature average is 38.4 degrees, which it is in GTA for the typical year, then I can tell you for a fact that you're going to use 725,760 BTUs per hour to heat that, as long as we know that those are correct inputs. So if we convert that to natural gas and use some efficiency, so natural gas required to heat the airflow is NG airflow. Heat required comes in. Efficiency of the unit is eta, and conversion factor is just to get from BTUs to cubic meters per hour. That's how much natural gas we'll use. So again, we put all those inputs, 22 cubic meters per hour. This particular unit, 20,000 CFM gets you 22 cubic meters per hour. That's a given. And then if you multiply that by the number of hours a year you're operating that unit at that state, 110,000 cubic meters per year for 5,000 hour operation. Again, typical operation in GTA. So that's fairly straightforward. There's not much room for interpretation here. But what I would like you to do is let's change it up a little bit. So let's do one more analysis here, one more exercise, and that I promise that'll be it for today. Exercise number 3, we have different inputs. We have 4 different cases, and you can choose to do either one or all of them, however you want. It's up to you. But essentially, we will vary. We will first change the indoor temperature to 66 instead of 72, leave everything else the same. Then we will change the CFM of airflow in case 2 to 16,000. Everything else is like an original case. Then we will change the efficiency. And lastly, we will change the number of hours. And let's see how close we get to that 110,000 cubic meters per year. Again, formulas are in the book. You essentially just plug in these for every case that you have. And on the next page, you have empty spot where to put all these values. So Q of airflow, NG airflow, and NG annual for each case. You can do 1, you can do 4, however you want. You have 5 minutes. If you have any questions, your ESCs are there. You can ask them for help. So one of the things that we should take from this exercise is the fact that when you do calculations, you could easily make mistakes. I could have made a mistake in any one of these. So having your energy solutions consultant actually look over the calculations helps bring the second set of eyes and say, hey, how did you get to that? And then it helps when two people see the same result and they can come to the same conclusions. The second thing that I want to point out is if you look at when we change what the reference case is versus when we change some of the parameters, the furthest from the original answer is the one when we change air volume and when we change number of hours. Now, this is not a very dramatic example of changes because it's a linear formula. It's always multiplying by same amount. So it's not that big of a deal. However, what is big of a deal is what we see the most. When we talk about makeup air units, people are terribly afraid for some reason to turn them off, even when there is nobody in the facility. So they will say, I don't want to turn it off, this 20,000 CFM makeup air unit. I will leave it at like 20%. I will just take off 20% when nobody's in the facility. You're still using 88,000 cubic meters a year when nobody's in the facility. And when you go back and you think about it, what makeup air unit does, it makes up the air that process is using. So if there's no people in the facility, there's no process, there's no need for makeup air. But people tend to turn it on because we don't want things to freeze. I have yet to find a facility in which things freeze when makeup air units are turned off because all of you will have unit heaters. And they're always designed to prevent freezing. That's what unit heaters do. That's the only reason they're in the place. And we have terrible time convincing people who use not 20,000 CFM, who use 500,000 CFM every minute to turn them down because they're afraid of air quality issues. And we'll touch on that in some of the examples of what we accomplished with customers. So the takeaway is, even though this is not a dramatic example, there's two factors that are more important to get right than the other two. So it may be worth your while to look at those factors rather than the other two more closely if you have limited time and resources. Of course, if you have resources and time to investigate every possible permutation, perfect. But most of us don't. Any questions or comments on that? Okay, let's continue. Some customers, of course, will do this engineering analysis. Once they have all the inputs, they will do it on their own. They don't need anybody else. But majority prefers to work with somebody. It's either us, which is complimentary service to our customers, or they have their preferred vendor they would like to mull this over with. Either way, we can either give you complimentary service or we can provide some financial incentives towards the engineering analysis of the inputs that we have just got. This is an example of one of the analyses that was done by our energy solutions consultant for a customer to give you an idea of complexity of it. As is current operation in the first column there. What customer wanted to do is increase the supply of the makeup air to balance the building. This is a big thing that I also hear lots. I want to balance the building. My building is negative, so I want to install more makeup air because to balance it. Look at their estimated natural gas consumption from the meter as is 400,000 cubic meters. If they were to balance the building, they would use 1.5 million cubic meters. You may want to ask yourself, is it worth balancing the building that much, to pay that much more? Look at the jump from kilowatt hours per year, from 1.1 million kilowatt hours to 1.9 million kilowatt hours to get that fresh air back into the building again. So then we did, okay, if you only run process exhaust and the smallest exhaust fan in the press shop, what do you get? What do you run with additional half air changes for winter only? What do you do with no press shop exhaust? how much air do you need to get the same amount of effort, same amount of comfort as you get here? We just make up air. So we did all this analysis. That's 1, 2, 3, 4, 5 different as-is scenarios, what-if scenarios for the customer. They chose this one. And we just checked on them 2 years later. They're actually not using 400,000, they're using 275,000 cubic meters. Because not only did they reduce the exhaust, they also tied now exhaust to their process. So if the process doesn't run, exhaust doesn't run, which further reduced their makeup air requirements. Yes? Yep.
But we have some random exhausts going on.
Yep.
The other one is I had reclaimed 3 out of the 5 compressors of air coming back in.
Mm-hmm.
And that's kind of good, but there are balances when it's not being.
Mm-hmm.
And I'm not sure how to balance.
Talk to us. We will figure it out. This is. If I have to, in Ontario, in our service territory, if I have to quantify the biggest potential for energy savings, it's the air makeup units. I would estimate 80% of the buildings will run with 150,000 CFM or more negative pressure. And I will touch upon that, how we handle that a little bit later to give you a little bit more detail. All right? We can talk about that.
Yeah, not only is that it's not compliant, but it's, I find backdrafts in my process.
Yes, yeah. Well, exactly example that I'll give you will address that. And then we can talk about a little more with everybody else as well. And then once we have all this business case built in, the other thing that people don't pay attention to is non-energy benefits. That's a relatively new phenomenon. Even in the general energy efficiency world out there, there's very few papers that touch upon that. But one recent one has identified that about 24 to 250% additional benefits from non-energy benefit from the energy savings. So whatever you saved on energy, another 250% potentially value is in other non-energy benefits of the project. So of course, that can be used as a driver to justify some projects and reduce your payback periods if you know what to look for and if you know how to quantify them. We will never know how to quantify them if we don't know what to look for or how to do it. So here's a couple of examples. They're not all-inclusive. As I said, this is a fairly new field. And all I can speak of is the things that we've seen that we have actually influenced and addressed. So these are not academic examples. These are now examples of what we have seen. So the first one is improving space conditions. Increasing the employee comfort improves labor productivity. Like Carol was mentioning, cold drafts, cold spaces causes walkout. That customer that I just had the business case for, they actually had a walkout 3 years earlier in the middle of the winter because it was so cold in the facility. So it reduces absenteeism, improves labor retention, improves well-being of the employees. I don't think there's any question that if employees feel good in the facility, they will be more productive. I don't think that's a question that anybody can question. The other part of non-energy, sorry, yes? Well, that's a soft thing. That depends on the facility, right? For example, these guys had actual case where they said, we had a walkout. So what is 8 hours worth of production worth to us? Because the machines go down and you don't make production. They were also in the car business. And I can't stress that enough. Every time you bring any sort of disruption to the supply chain, you're hit with very heavy penalties. So they had invoice for their walkout. Well, that's what I'm saying. It's difficult. It's like, right. So maybe it's the matter of productivity. Are the people more productive? Can you measure that? Is there a measurement? I don't know. We didn't have energy savings where I used to work before, but what we did have, we were unionized, And almost every workstation had a big thermostat in their workstation. And if that was over a certain limit or below a certain limit, they would just walk. It's very clear how to quantify it then, right? So I would agree. It's not, you can't put direct dollars, but in certain cases, you can actually attach value of certain sorts. So I hope that answers your question. I'm sorry I'm not more definitive, but there is no such thing as big definitive things. The other thing that we also have to worry about is water. 70% of Earth's surface is covered by water, so why do we worry about it? Well, 97.5% is salt water, which means 2.5% is remaining for some sort of usage. The problem is that out of that, 3/4 is in the glaciers and all sorts of elements. 2/4 is in the soil we can't extract. So it means that only 1% of 2.5% is available for our use. And of course, people notice that. So multinationals nowadays look very closely at how much water they use. The water usage has become much more important than natural gas usage for most multinationals because it has high visibility. Everybody worries about water. You can paint it very easily. If you're somebody against the industry, you can very easily put placards around the facility and say, you use too much water. You don't allow somebody to drink water. That's a big issue for some people. I can't speak from personal experience, but I've talked to the customer in our service area who has a facility in Australia. This is a #1 for them. They will spend all amounts of money possible to save water because Australia doesn't have it. And every multinational nowadays will look, how can I save on water? So sometimes, can we use water savings as a non-energy benefit for our projects? Because typically what happens, we use energy to heat the water or cool the water, whatever we do with it. But energy is used. So if we attach value, if we can reduce water, as we're reducing the heating energy, we're also reducing the amount of water. If we put that, that's very quantifiable. We can put it into the business case. And I'll show you one case later on where we've done that. Yes?
In my business cases, I have to put carbon footprint impact also.
Yep.
Not only the ROI, payback, saving, but carbon.
That?
Yeah.
Absolutely. No, that's perfect. That's what we want. This workshop is for you guys to give me feedback just as much as I am to give you some feedback. Slides are just there that we can talk about something. But essentially, if you want to reduce emissions, in Ontario, cap and trade has gone. Questions are now whether it's going to be federal tax or not. Who knows? I'm not here to decide the future. What I'm here is to say that if you are worried about your emissions, reducing the volumetric consumption of your natural gas is the best way to reduce emissions, period. There's no question. There has been worldwide studies to say if you're energy efficient, that's the most cost-effective way to reduce your consumption, and reduced consumption leads to reduced emissions. Therefore, using your energy the most efficiently will reduce your emissions in the least cost fashion. So yes, again, we can buy fancy new machinery, we can be Energy Star this, Energy Star that, but effectively, if you just use what you have properly, you will reduce your emissions for much lower cost in general. And that's what we're driving for. So that's the third non-energy benefit that we talk about. So those are 3 things that we know because we've done with customers some analysis, we know where they come from. But again, it's very site-specific. What's important to one customer is not important to another customer. They have some other importance. And where energy solution consultants come in is to say, okay, I know what's important to you, so we will tailor how we show this to your benefit so that you get approved project. So this is the reason why we actually do all this. Yes, we're an energy company, all that good stuff, but I like to think that we are really connected to industrial and manufacturing facilities specific. If we like to understand them, we like to help you get further. So there's different reasons why we have jobs, why we have customers as manufacturers. It can be good sales. We can be really good at marketing. We could have some unique process that nobody else has. The reason we were making so many springs in Milton for a long, long time is because we had specific process to Toyota only, and Toyota would not make coils anywhere else but with us. So we had unique process, we had that, and that translates into benefit. There is benefit that we bring to the market that nobody else does. On the other hand, of course, nobody's going to pay you any amount of money. You have to control your costs. That brings the cost advantage to your customer. And where those two meet, benefit and cost advantage, is what we call value proposition. That's why customer goes to you and not to the guy next door. Because you can make what they want at a cost they're willing to pay. Simple as that. So when we do energy projects, this is what we have to keep in mind. This is what we always keep in mind. Because energy savings will, of course, reduce your operational costs. I don't think there's any question on that. If you can reduce your bill, utility bill, you will improve your operational costs. So, which means that your cost advantage will rise. You will be more competitive. But unlike any other cost-cutting measure, any other one you can think of, energy savings can also reduce the carbon footprint, improves your public image, enhances working conditions. So not only you get cost advantage, you actually improve your benefit that you bring to the marketplace. For us, cap and trade comes and goes. We are slightly different here in North America. Who knows where the future will take us? But I can tell you in Europe, large corporations are now either starting or will start next year to report their supply chain carbon footprint. So if you want to be in supply chain for somebody who captures carbon as a line item, whether you pay carbon costs here or not is irrelevant to how you're going to report it and how competitive you're going to be on the world stage. And if you want to do that competitiveness in a way that's cost effective and it's not going to make you broke, energy efficiency is the way to do it. Use what you have efficiently. You can make something 100% efficient, but if that's what you make is waste, then you just made a really efficient waste. You didn't improve anything. I would rather you make something at 50% efficient but useful than 100% efficient and waste. Makes no sense. So, to drive project implementation, we need to get project funding. No project funding, no project implementation. Simple. We will get the approval if we present viable business case. And that viable business case, the purpose of this engineering step analysis that we're talking about, this engineering analysis, that's why it's so important to us, is to give you, to substantiate the business case that you're presenting. So that when you ask questions, and I had pleasant and unpleasant duty to present $2-3 million requests to the management. When you ask somebody, please give me $3 million, I know that you guys probably experience that. There is a lot of onus on you to prove why your $3 million will bring company benefit. And it's not like in school where it doesn't matter whether you pass or fail. It is very important. So we want you to have the right information before you go and ask for money. So again, please get the second set of eyes, have them take a look at it and say, hey, did I miss something? Can I improve this? What do you think? Is there incentives that are going to reduce our first cost? Action and implementation, last step. Arguably, it is the key to realizing the savings. And I know that the second sentence will cause like, yeah, right. It is the most straightforward step. But it's only straightforward if we've done all of this stuff before. If we actually went through the steps we said, then it will be the easiest step because you already know what you're presenting, you know what you're asking, you know what the benefits are. And the last bit that is really important, all along, the reason why we're asking for 50% investment on the energy assessment from you is that somebody else but you in the facility knows that this is going on. That this is not entertainment of one person or let's see what happens. That organization actually bought into the idea that Yes, this is worthwhile for everybody. So when you present business case, it's not a surprise. So you do all this work, you quantify everything, you spend effort and time, and you bring the business case, and they're like, yeah, well, we don't want to look into it. You want to have that buy-in from the management that, hey, if I do this, these are the potential benefits. Are we looking into this? How we present that? Those are the things that sometimes energy solution consultant can do for you. I don't know how many cases I can name you where if you go and ask your management or even your people on the floor and you say, we should be doing this, they're pretty much ignoring you. I know it happened to me. But you bring the consultant and he does exactly same slide and management goes, yeah, that's a great idea, let's do it. I don't know why, but it happens. So if you need that help, we like to stay in the background just because we want you to be the face of the project. We want you to get the benefit of it. But if you need somebody to be that second set of eyes or somebody outside who says, hey, you know, the company who sells us gas tells this is how we're going to save it. If that's of benefit to you, let us know. We can do the presentation to your management. It's not a problem. But that happens very often. So only customer, only you are the one who can decide to kick off the project. We can do all this work. We have done work with customers before. At the end of it was we can't get the funding or we're not going to go proceed. That's OK. That happens. Our help to this point is not tied to you actually executing the project. We understand that that happens, as long as we have agreement that you will try to get a project. But once you do kick off the project, now it's mainly onto you. You're and your vendor. But that doesn't mean that we are out of the loop. We can still help. We can bring the vendors together. I used to bring 3 or 4 vendors to the customer. I organize all the meetings, put all the agendas together so that customer doesn't have to waste time ahead of time. So we can do that. Or we can offer financial help. Financial help is incentives. And they are available. So once you execute a project, we will give you incentives that are tied to the project calculated savings. But let's talk about them first in more detail because they're easier to understand. So the more you save actual energy, the higher your incentive will be. I can give you now the incentive level, but it's really of no use to you. You can get it on our web pages. You have it in your brochures. You have that. That's not of use. What is really critical here is we will try to find you project that will get approved based on the merit of the project, not on the merit of the incentive. Incentive should be looked at as a cherry on top. There is no point in executing a project that has really good incentive and the payback is 20 years. We would rather you find a project that we find opportunity that pays back in year, 2 years, with actual savings that will then persist for 20 years and give you an incentive, then look for some unicorns that don't exist. Fine print, of course, about incentives does apply. But if you worked with energy solutions consultant up to this point with all these steps, by this step, by the time you put business case together, you will have promised incentive that you can put into your business case, that you will get from Enbridge once the project is implemented. So you do not have to wait. You do not have to guess. You will know. If you worked with the energy solutions consultant, by this time, you will know exactly to a dollar how much you're going to get. Yes?
What are the conditions of these incentives, such as like the period of execution or in certain state?
They're based on annual. So we have to have project. If we say the project will be done this year, it has to be done by December 31st this year. Multi-year projects we like to break up into into smaller projects. But what I had a project, and all of my guys had a project. I had a project for 4 years. So from the start of the project, when we actually talked about it, when we quantified it, it took some approval. It was only executed in year 4, and we still gave them incentive that we promised at the beginning. So. No, no. Yeah, for us, our terms and conditions are one page at the back of the application. And pretty much we say we will calculate the savings. If we agree to the input conditions, this is your incentive. There is no other requirement on your part to do that. For some projects, selected projects, there will be external audit done by the Ontario Energy Board, usually a year or two afterwards, where they will go and say, hey, these are the inputs. Do you agree? Are these inputs okay? And then they will calculate using our calculator anyways. So as long as we didn't change input conditions much, there is no problem. Even if that happens, we will not go back and claw back incentive. We don't do that. We want you to be sure what you're getting, and that's what it is. So much different than ISO procedure. I'm not going to be mean to them, but I would not be willing to work for them. Let's put it that way. Yeah, we are very different. Maybe this is a good time to mention to those who haven't participated yet, who haven't done this. Our ESC, our energy solution consultant, will actually fill in the application. All you have to, literally, all you have to do is sign on the bottom. There is no other requirements on administration from your part. If we need to quantify something, we do it not because we want to be sure. We want you to be sure that the project works. That's why we want to do it. So yes, there will be some work ahead of time if we need to quantify it. But administratively, one signature is all it takes. So resource help. We often ask, recommend the vendor. Okay, you have great idea, now tell me the vendor. We do not have a list of preferred vendors. If anybody comes and says, I'm a preferred vendor of Enbridge for industrial program, they're not telling you the truth. We do not have them. They don't exist. We can provide you a list of vendors that we worked with in the past, but they're all equal to us. We do not say this is preferred, this is better, this is worse. We do not do that. And the reason we don't do that is because in our experience, industrial manufacturing facility will already have a whole bunch of vendors they work with day in, day out. They build trust, they build relationship with all sorts of vendors, with all sorts of trades. And energy projects are not that unique. I don't know where that came from. They're not different than installing any other piece of equipment. If you're installing TSSA-specific piece, you need somebody who has TSSA approval. But your gas technician will have TSSA approval. Your gas tech vendor will have all of that. So these are not some sort of special exotic projects that everybody has to be afraid of. Anybody can do it. Most of the projects turn out to be controls. How many of you have already controls guy who does the PLC programming for you every day? It's not different. It's just input outputs. For them, it's all the same. Spark is all the same. So for example, that project that we talked about, now we're going to talk about some of the projects that we've seen. That opportunity that we talked about, 24% consumption during weekends, 300,000, so about 25% of their consumption, that turned into ventilation control project. And the customer would not believe me that they actually used this. Luckily, he lived close to the facility, so he went on 2 Sundays, subsequent Sundays, when there was nobody in the facility. He went into the facility. Lo and behold, all makeup air units were operating. Full blast. All of them. So once we realized that, we got together. I brought 3 or 4 of the different vendors, random vendors. He brought a couple of their own that they work with. And we agreed. We chose a vendor that they used to work with on PLCs. We connected all of their makeup air and unit heaters and exhaust fans onto a number of nodes. So we had zonal controller with inputs and outputs for all these nodes. All of them were feeding the microprocessor-based facility controller. That information went to the PC-based user interface and the historian. And they also had internet connection. So if the unit was operational outside of scheduled time, he had actually got on his smartphone, he got the notification that says, equipment's running, is that okay? So this is what they produced themselves, their vendor that did PLC programming. In the end, they did this on their desktop. They put ventilation, summer schedule running, heating, spring, fall schedule running in this particular time. And they also attach their lighting to the system. So they can control lighting based on what line is operational. There's no point in running all the lights in the facility if they are not needed. So he could do this all from his desktop. This is what they saw after implementation. This is summary of the implementation. This is consumption before. This is consumption after. They saved about 25, 30% of their consumption by doing that. $140,000 investment, all included, all audits. This is a unionized environment, so we had air quality audit before and after. We had design, pre-design approval. We had design stage. We had install. All the hardware, $140,000 for about, they had 38 makeup air units and something like 120 exhaust fans that were all tied into this. So large system. This is not a small system. They reduced natural gas by 360,000 cubic meters. They reduced electricity by 1 million kilowatt hours per year by turning off exhaust when they don't need them. And lo and behold, nothing froze. We actually put data loggers, temperature data loggers at different heights before we turned the system on to make sure that over the weekend we turned off the makeup air units and we monitored the data of the temperatures close to the pipes, near the ceiling, halfway down at the bottom, to know that nothing's going to freeze. From their set point of about 21 degrees Celsius, over the long weekend, that was Easter, so that would be somewhere in March. Over the long weekend, the facility has lost a grand total of 3 degrees Celsius by not using makeup air. So they were still at 18 degrees Celsius when they came back to work Tuesday. So no potential for freezing. So savings payback, including our incentive of $28,000, 0.6 years, half a year. They managed to save $181,000 in year one. I have email from the customer later telling me that he's afraid that he set the bar too high. They actually implemented this system, but for the summer mode, for air conditioning down in their facility in North Carolina, the year after. No specialty trades, no big projects, no big vendors, simple installation. And of course, because they unionized the environment, we gave union to pull all the wires between the units, so nobody complained about having the vendors do the programming. If anybody cares, that was the savings, 675 tons of CO2 equivalent by doing that project. Other one, you remember this one where one is freezing, one is nice and toasty? That became exhaust reduction system. That's actually the facility where I showed you that business case that had multiple operating parameters. What really happened, every time you have this imbalance, is people put process that requires makeup air into the facility. And then they, by design, because everybody who does this kind of job and engineers have to put the same amount of makeup air, minimum, to balance the two. But what happens is, then this process starts emanating heat, which gets more pronounced in the summertime. So they complain, it's too hot, I can't work here. So plant managers, to do it fast, efficient, and effective, they drill a couple of holes, they put exhaust on top, which is a valid solution. I would do the same. Problem is, those are not tied to anything. So when the winter comes, you have all this air pulling through the facility by that imbalance. So you have this guy freezing, and then we have people installing infrared heaters or air curtains, all sorts of stuff that don't work. As long as you have that much imbalance, they do not work. And what would happen is cold, drafty space. because usually this equipment is somewhere off to the side or in the middle of the facility, far away from the shipping. So not only this guy is freezing, but he's now okay because you have all this infrared right on top of him. Now the guy here is freezing. Then the guy here is freezing. The whole facility is cold and drafty. And then they call and they say, we need to balance the building, let's put more makeup air. And they pay penalty for that makeup air. These guys did the other way around. We actually managed to talk them into not buying makeup air, but controlling the exhaust, how much exhaust you have. So they installed and designed their own PLC system. It's a very simple system, fits onto their PLC screens. All it does is connects makeup air to the exhaust and exhaust to their process. If the process does not run, exhaust does not run. If exhaust does not run, makeup air does not run. $44,020 in investment, all of it. Audit, design, installation, the whole thing. Avoided, because what they wanted to do versus what we ended up doing is 800,000 cubic meters that they avoided paying for. 800,000. More importantly, 1.2 million kilowatt hours that they avoided paying for. So the payback is almost instantaneous. Those are the people that year prior to this had a walkout because it was too cold in the facility. Those are the people that actually nowadays don't use even as much as they used before. They further reduce their usage by another 100,000 cubic meters by just controlling the system better. And those are the same people that today, no matter where in the facility you are, on the coldest of days, because now they have data everywhere, is 18 degrees Celsius, including next to the shipping doors. That's what we're trying to do. And this took first 5 meetings, Slova, 3 or 5 meetings. It took just to get them off the train. We need more makeup air. We need more makeup air. We need more makeup air. No, you don't. Why do you have exhaust? Yes. And he almost certainly does not need more makeup air. Because
there's another side note of what they call recirculation.
Yeah, these thread fans?
I'm saying that maybe we should look into that a little bit.
Yeah, if you have pockets of hot air.
Applies to our reprocess.
Yeah, but you always have to be cautious. These thread fans work in certain applications. You always have to be careful. I had customers who had this thread fan installed, believe it or not. I don't know how many of you will recognize, but on the roof, you sometimes have those 4-foot big fans. It's like a hole. They put this thread fan underneath 2 of those. And you're like, why you have fans then on the top if you're going to push all the air down? Why don't you just turn off the exhaust fans in the first place? Right? So you have to be a little selective where you put it. First thing is balance the building properly. Reduce the exhaust that you don't need, especially in the wintertime. Nobody says in the summertime. In the summertime, run all exhaust you want because everybody keeps the doors open anyways. But in the wintertime, control how much you throw out. Savings of 1,490 tons of CO2 equivalent, which was significant. Yes?
As you explained, the Enbridge oversee all this project. Who does all this calculation and implementation tasks?
Sorry?
As the Enbridge oversee the project, or Enbridge does calculate all these parameters and payback and present it to the company?
We can do it any which way you work, but we usually do the calculations, we do quantifications for you, we help with quantification if that needs to be done by the third party. We essentially prepare the ground, so when you do the business case, you know what you're getting. And then we tell you this is incentive you're going to be getting for this type of savings. And then it's up to the customer to actually execute the project. Okay? I have a case now where a customer wants to insist on installing 144,000 CFM of air because air quality is bad. The same customer who was at the same location working the same job with the same equipment for the last 20 years. All of a sudden, they have a problem. So we're going to talk to them and see if the problem is maybe one of these things. Third case, spot opportunity. Remember the purge requirements and how operation requires a fraction. And most people who don't have direct experience with these ovens will say, big deal. Well, the problem is, for a typical gas-fired convection oven, if you put 100 units of energy in, these are the losses, you will get 22 units of 100 units of energy actually into the product. So remember how we talked about heat to load that you actually need? 22% of your overall heat you paid for. 44% goes into exhaust. So if you look at it that way, this becomes a completely different business case. Because that little puff is actually 44% of your energy. Half. And that's typical. I've seen people who have 65%. So this is not this is average. So what we've done on one of them, we actually helped them in installing not only the fan that took the cold air, put it through the heat exchanger, through which exhaust then heated the incoming air, but we also reduced that exhaust volume as well. So we went down. It has VFD on their exhaust, because in the past, VFD was expensive. So ovens that are now 20, 30 years old, and most of ours are, will have no VFDs. So you can only run one speed, and your speed is limited by the purge requirement. So it dumps all that air out. You put VFD on it, you program it so that once the purge requirement is satisfied, you go down to where you actually need the exhaust. And that's fraction of what the purge requirement is. So these guys actually save by investing $30,000 in a heat exchanger, 2 VFDs, additional fan, all the ducting, and saved 100,000 cubic meters of natural gas. In this case, because they installed additional fan, they use 4,000 kilowatt hours more of electricity, but it still gets them to about 0.7-year payback with our incentive. And in this case, incentive was exactly half of the cost of the project because they maxed out. So for $15,000 investment on their part, they are saving 100,000 cubic meters every year, which ends up being about 184 tons of CO2 equivalent. Very simple project, no effect on their process. Even though it's a process equipment driven, we did not change anything on their process at all. All we've done is we reduced their losses that they were generating every single moment. We talked about water as well. So this is a little more complex project. So before project implementation at this facility, what they've done is they have parts that they need to wash in 3 stages. Stage 1, stage 2, stage 3. Parts flow that way. So they had processed water at 15 GPMs in each stage, 15 gallons per minute. In the first 2 stages, it was a processed water, just regular city water, heated. That was heated by steam through the steam heat exchanger. And then for the other 15 GPM, at the last stage, which was critical for their process, they actually use RO water. So they heated RO water with the heating water that they generated in direct contact water heater. And direct contact water heater, for those who don't know, is the most efficient way to generate hot water. It's almost 100% efficient because you use exhaust gas to preheat the cold water by dripping through the exhaust gas. So you get all the latent and the sensible heat out of the exhaust, and you get the most benefit. So usually you get 95% efficient. Problem with these guys is they had it on a closed loop, and therefore their efficiency was really 50%. So they had really low efficiency on this one and on the steam boiler. So what we decided to do is, in a number of steps, then they drain that, of course. Stage goes there. In the number of steps, so first step was, let's reduce the water. Do we really need 15 GPMs of water? Turns out, after a number of tests that they've done to ensure the quality is still okay, that they needed 5 gallons per minute on the first 2 stages that are not as critical, and we settled on 10 gallons per minute in the last and most critical stage. That's what's needed. Then we said, okay, we will actually take some of this drain water, this 10 GPM of process water that's not critical, we will reuse it. Instead of draining it, because it only went once through the process, it's a fairly clean process, we will just reuse it. We will not drain it. So now we're saving 10 gallons per minute of water not going to the drain. We put natural gas water heater in there. Instead of using steam from the central plant, we put natural gas water heater next to the unit. So now we are at 92% efficient heating, and we only bump up a little bit. This water actually loses maybe 30, 40 degrees F. So instead of draining it and then heating the water from 50 degrees F to 180, now we just go from 130 to 180 every time. And we don't use city water anymore as much. And then we'll drain just a little bit, this 5 GPM that we need to drain to make sure that everything's clean. In addition, this water, instead of being heated by direct contact water heater, we will actually install condensing economizer on our boiler. Because this process runs constantly, it's ideal application for condensing economizer. We skipped. They didn't have any economizer, so we didn't even bother with feed water economizer. We just put condensing economizer on it. And that's wasted heat is preheating their RO water. So by doing that, these are the savings. $276,000 investment, condensing economizer, all the piping, all the metering, all the testing that we've done, saves them 657,000 cubic meters of natural gas a year. 657,000. Savings 183,000 cubic meters, $183,000. Our incentive, that's the one that we worked for 4 years. We gave them this incentive level 4 years prior to this project implementation, because they tried and tried and tried and couldn't get funding from the corporate office. And we kept trying and trying and trying. What ended up being in the year 4, just like it happens probably with your facilities, at the end of the year, usually everybody in the front part of the year, they're like, we don't have funding, we don't have funding, we don't have funding. And then comes October and they're like, oh, we have all this funding left over. Who's got a project? Let's get it done. That's why we want you to prepare business case before, because at that time, it's not time for you to go, oh, let me investigate. It's not investigation time. Who can put it on their desk wins the prize. And that's what happened here. It's a 1-year payback, and we still fought 4 years to get it going. Now, that's 1 washer out of 6? 6 washers in the facility. So now they've done that to all 6 washers, reducing the water. They went from one of the biggest users in their town of water to one of the smallest users. They reduced their natural gas consumption by about 40%. And not only did they save energy, now they shot up from the corporate level, from almost closing a few years ago, to now being the top dog in their corporate level in North America, and they got contracts from the US plants that they moved here because they're so cost effective. That's what we want. So yes, incentive is important, but what we want is that benefit, that $183,000 year after year, you will get the savings. They also saved, if they counted that, 1,233 tons of CO2e, because they're a corporation that is global and they work a lot of jobs in Europe. That's important for them. Whether it's cap and trade or not, that number is critical for them. It allows them to claim on a corporate level a lot of benefits that they wouldn't otherwise. So that's another benefit that they claim. It's non-energy benefit, but it's very important for them. Any questions or comments on these examples? One thing I don't want this to become is I don't want people to take this away and look for exact same opportunity that I've seen here. The idea is to say, is there any waste potential? And what can I do with it? Let me call our energy and solutions consultant. Let's just chat about it. If you don't have time for chat, send an email. It's okay. Like, we don't mind. If you have reams and reams of data and say, can you find something? Send us the data. We'll look through it. We don't mind. We really want you to be successful. That's what we want this to become. So in closing, sometimes there's a lot of stress on us, especially in energy efficiency projects. There's so complex. There's such complexity in all of this. We don't know, do we have the funding? Will we make somebody uncomfortable in the facility? We have all these effort that we have to put in that we see, well, maybe it's not worth it. Why would I do it? Nobody else does it. Why would I do it? What the goal is to say, hey, you have help. We can help you. We know you have opportunities. For sure. Everybody does. Let's try to find them. And I can guarantee you that the potential is worth it. I talked about how 80% of the facilities in Ontario have at least 150,000 CFM over exhaustion. 150,000 CFM is costing facility $250,000 a year. Is $250,000 saving not worth at least looking into it? That's all we want. So we have been around since about that mixtape was being made, way before CDs, way before iTunes. We work with our customers. We don't have cookie-cutter solutions. We don't do that. Everyone is made for you. We put our customers' interests first. I cannot tell you how many times we talk to the vendor and say, no, we disagree with the statement. We want customer to get the benefit. And we find solutions that maximize the savings. We don't want to give you solutions that's going to cost you millions of dollars and have 20-year payback. Anybody can do that. We want to find solution that's going to win you the business case. And an Environmental Commissioner of Ontario in 2016 actually said that every customer saved $2.67 for every dollar invested in natural gas conservation. So it's not just me saying this. This is public information. It's worth your while. So to close this off, we have a campaign. Between now and the end of the year, we will double the incentive for heat recovery projects, up to 75% of the project cost. Funds are limited, so first few projects when we spend the funding, that it's all gone. So talk to your ESC, sooner the better. Also, remember the stuff that you filled in the projects, that you have some ideas that you haven't issued PO yet, but you're hoping to get it done this year. We will actually give you extra $10,000 on top of your incentive if that project gets executed this year. And we will do the prize for every customer who does a project of a certain size. You will get a prize at the end of the month.